Hello, I will use the quiet of the night or whatever to talk about some stuff. Hello Internet. I try to improve my recording quality when the CPU is busy. Unix is not so simple. This is what you try to do to get the recording to improve. Give the recording process higher priority. Let's hope that it works. What am I doing? I'm making an autocomplete, a very nice autocomplete function. Where is my autocomplete? Here it is. I just type something and it queries the smart bot, which is sitting on the server over there. No, here. And the smart bot gives us completions of whatever we type. Little Java interface here. And when I press enter, it sends me to the bot page, which should show us the semantic graph around this thing we typed. It's a bit of garbage, but also some good information in there already. It relates things to the individual words. And here it switches persons, for example. How am I? How are you? Yeah, it's a basic part of dialogue, isn't it? Still, the bot is kind of... This is the Java heap. It's not very big. It has 822,000 statements of information in 100 megabytes. I'm still quite happy about this ratio here. This is how I program JSON encode. Now JSON, the format, you probably have seen it. Let's look at the example here. This is the actual page that is called by the autocomplete. Very simple URL. And it returns some JSON. Simple object format. 10 options by default. And this is a JSON encoder. This takes a Java list or map or a list of maps or standard Java structure and turns this list or this map into JSON. Other people make JSON toolkits, right? JSON Java library. There are like many libraries, and I bet they are really complicated. They have their own sets of classes, and they have what have you. It's really, really complex stuff. Each of these has a different API, and I say let's use the Java API because Java has a map which maps objects, map interface, and Java has the list interface, which is a list of things, and these are so useful, and they can be packaged inside of each other, and and this is the whole JSON encoder. This thing, it's the luxury version with line breaks. We have line breaks here after every line, which makes it easier to read. And this is the JSON encoder without the line breaks, 36 lines. And here's the luxury encoder. It just checks what you put in there and it outputs the JSON string. These 38 lines replace whole libraries and whatever days of training. This is the way to program. Really, this is so much more efficient. Okay, let's stop the praising for a little moment. Let's say I want to change something. I change something in the encode function because this is not perfectly pretty. I want this end of the list to be down here. Alright. So I change something in the function here. Here it is, the end of the list, and I say if we're at the we want, if this had more details in every item, we would not want to break all the time. We just make line breaks at level 1. This is level 1 here. It doesn't matter. Do the same thing somewhere else. Doesn't matter. I change this function on the server. It's already, this is versioned automatically also. And if I want to apply this to my bot, it's like one keystroke. I say, please build the bot again. And it starts to JavaX transpiler and everything, and makes new Java code. It does get a little longer because this bot is huge now. The bot has, right now you can see it, but it has 37,000 lines of Java code. It's working on 4 cores. This is my own transpiler, which makes Java code. It's all my code. And it is using all 4 cores here. Now it does some final touches to the code. It adds public modifiers to the whole code because Java wants this. Java wants stuff to be public to allow for inter-class loader tricks that I do. I kind of trick class loaders. I can merge programs at runtime in full speed. I can extend code at runtime more or less. This was pretty slow, probably because we're recording. And now the server starts new. The bot starts itself. Here, the bot says, oh, I'm gone. Because it noticed that there's no new code. This is how I deploy my code. I just say, please upload to the server, and then the client finds the new code and restarts itself. It's called auto restart. Now the bot is loading, and it's still returning. It's serving this web page every 5 seconds. This bot is very flexible. While it is loading, it can already answer questions. It just might not have answers because it's still loading its database. Still loading. And in a second, actually now, we'll have our new code here. Now this is even prettier. How are you? How old is the universe? How old is it? Oh, the answer is missing. We will improve this semantic graph now. Next thing we do, I swear. But the main thing I wanted to show you is this document here. This is good stuff, man. How we get the robots to talk and think like humans. 3 steps. And you will notice that the first step here, making a rule engine, like an engine for rules that we specify in English, is something that other researchers don't do right now. Everybody right now seems to do this. If it's actual AI, they say it has to be a learning system, a neural network, mostly, or some other math. And they say we'll make a learning system. But this is not going to lead to the kind of AI that we actually want. I say let's do this here first, because this is making computers speak English. Slightly simplified English, but it's already English. First we make something that we can drive, like a car. Second, we find out where to drive the car. Or the car drives itself, because what is thought? Thought is something you could think about anything, basically. If you have a working brain, you can think basically about anything. Anything that interests you. But how do we direct this interest? Direct the interest. We have to specify some rules for the bot. What it should be interested in. If I say something, it should be interested in what I say. I guess, because I want a bot that does stuff for me. So how do we want to specify this? We want to use English, so we need this engine up here. This is like a new programming language. It's just way better, super flexible. It's like a programming language you don't have to learn because it learns your language. Very simple rules these are going to be. And lastly, we have a learning system that optimizes its own parameters. But this doesn't really require much learning. Well, it does require some learning if we specify ambiguous things. Yeah, anyway, this is the plan here. I find it so funny to be like outside of the regular, mainstream AI research, but actually coming up with these things, because this is how it's going to work. I've been studying these rule engines there for a long time, in university too and everything. There are rule engines like, it's called mod. Yeah, it's also a train apparently. No, the mod system here. I've worked with it a lot. And it's a very efficient engine that applies rules. But once again, it has its own language. And this language is once again restricted. And we are once again going down to the computer level, but we want to stay up on our level. Just talk English. And see, this is the manual. And you have to write things in very specific ways. It's basically another programming language that is just a little bit more flexible. Yeah, this is very complicated also. You can declare your own operators. It's interesting. It goes beyond normal programming because it is kind of like making your own language. It has a parser you can define yourself. But it's still limited. And it's not English. I don't want to write this here. Up underscore plus colon stuff. Non-zero natural integer. No, I just want to say integer. Or non-zero natural integer. I just want to speak English. I have a chat here. So, this is the plan. Get in the boat.